In this new video, we will discuss about DT, destructive testing. So first step is we need to skip the two slides regarding the inspection for the welders. That one we will do first. Okay. So these are the inspection areas. Base material to be specified, joint design, filler type and size are correct. The required welding equipment, tooling. Tooling can be adequately tested to determine it will support the operation. Then, then parts have been properly cleaned. Welding training certificate and training and certificate is sufficient for the weld operation. Proper welding procedure is used and the welding equipment set up properly for the and inspection and tests required during the welding operation and performed as specified. There should be a checklist for all those things. Okay, that's about it, about inspection areas of the welders. So we have finished up to here. Now, bend test. Purpose of the bend test to check fusion or lack of fusion, soundness, cracking in the weld and the heat affected zone. So it is bend around a mandrel until failure or a specified angle, and with weld area either outside or inside. Outside is called face bend, inside is called root bend. So what it shows actually, it's we are checking absence of carbon or lack of absence of cracks or lack of fusions, ensuring flexibility. And what is a impact test? Impact test, we are assessing the toughness and energy absorption. Especially it is this toughness test is critical for low temperature services. So a pendulum strikes a notched specimen to break it, and the absorbed energy is measured, and we are checking the brittleness of the weldment. Then we have this other test like hardness testing. Check hardness profiles across the weld, um, metallographic examination like weldments, microstructure, grain size, phases, etc. And when we have corrosion testing, performed this test application requires a corrosion resistance. So role in the PQR, it's all done on the test coupon that simulates the production weld, and the result document the actual weld parameters like ambience, voltage, speed, etc. Confirmed WPS is valid for production use. Okay. So we have bookmarked one YouTube video standard guide for how to pass a bend test from well.com. So it is showing the bend test actually. Uh, so what first we are seeing is how he is preparing the um from the code. He is preparing the sample to be tested. It is a AWS D1.1 2015. In this, it is described how to do the prepare the um, bend test specimen. So he is preparing from the diagram shown in this particular code. Okay. So this is the code, that is AWS D1.1. He is checking the tables mentioned uh, for the welder and welding operator qualification. So this is he is checking the figure for from that figure he is getting the thickness, range of thickness and all. So he is preparing the root face and the is writing root one area, face one area. So he's said if is written face and here is written root. Now he'll grind it all the protrusions to get a clear test specimen. This is for the what you say backing. It's a backer. We don't require it. He's going to grind it down after fixing in a holder. So it's going to grind it. Oh, he has grinded it actually, like this. Now he has grinded it. We got like this, and is testing for a root. This is a reinforcement provided in the face. So is grinding that one also. He's he has grinded it in a manner like this actually, in that direction only, in this direction only, because otherwise it will create another line, may have make it can create a crack or something in the direction of the where we are doing the bend. So he is doing it in the longitudinally, not to affect the result. So this is a grinder they are using. Is checking doing the sides also. Like this, he prepared this one. Now is doing the test. He's saying that the face one we have we don't want a long curvature on the face, so he will do it. The machine has to do a lot of work first to make it straight and then bend it like this. Okay, then he's doing the test. He's centering it, then applying the load like this. Ah, illa. So it is this is how this bend test is working. We are doing the uh, root side and the face side. We are doing this test, doing this bending, and check for any cracks are forming, any fusion. Particularly, we are doing this with the MPT or something dye penetrant to see if there any cracks are formed or not. Like this, they are doing the face bend actually. Bristles are there, it is because of the backing plate, it is not connected to our this one is not connected to our weldment. Okay. So bend test is a qualitative test. It is used to evaluate ductility and soundness of the weld joint. So it is done by subjecting the specimen to a controlled plastic deformation. This test reveals defects like cracks, lack of fusion, or inadequate penetration that can lead to premature failure in service. So type of it is the codes are ASME 9, AWS D1.1 or ISO 9606 etc. First type is a face bend test. In this specimen is bent so that the uh, weld face, that is cap, is on the convex surface, that is on the tension surface. Root bend test is that it is specimen is bent with the weld root is on the convex tension surface. Then side bend test for thicker materials greater than 12 mm. Full thickness of the weld is tested by placing the side of the weld in tension. Longitudinal bend test uses when the parent material and the weld material have substantially different strength. The entire weld width is included in the test. The procedure is that the equipment uses a fixer with a plunger and die to force the coupon into a U shape or a specified angle, usually 180 degree. This specimen is precisely cut from the welded test plate. Sharp edges and corners are rounded off to a radius of 3 mm to prevent a premature failure from the stress concentration. Then the root and face and root surfaces are typically machined or grounded flat. Testing is done using a this fixer, or as it called a bend test jig. Force is applied via the plunger or a wrap-around mechanism, bending the and it bends the specimen around a mandrel or former of a specific diameter. This diameter can be 3T or 4T when T is the coupon thickness. So, or a specific this diameter is determined by the material types, thickness, and the applicable weld code. The acceptance criteria is convex outer surface is visually examined for defects, and if the test is a failure if the discontinuity or crack greater than 3 mm in any direction is observed on the tension surface or convex surface. Smaller cracks or minor surface irregularities are often acceptable. So this is done to ensure the integrity of the welding procedure and the proficiency of the welder. This is another photo of the bend test machine equipment. Now tensile test. This is the PQR of our site. Here they have done face bend. Mandrel diameter was 40 mm. All are 40 mm. Actually, we have done face bend and root bend. The angle 180. 180 means it come like this in the U shape, like this. So this is 180, and results are satisfactory because any crack or discontinuity greater than 3 mm not observed. That is why it is satisfactory. Okay.